Next, time complexity. Now the time complexity of an algorithm is the amount of time, computed time, it needs to run to completion. So basically two types of times are there, compile time and runtime. So here we'll talk about the runtime only. Clear? Now question is how to calculate the time complexity. Now one thing what we can do, we can identify amount of time required to execute addition, amount of time to use to execute multiplication and division. You just identify number of addition, number of multiplication and number of division. Suppose number of addition needs TA time, for multiplication computer needs TM time, for division it needs TD time, and for subtraction it needs TS time. Now in this particular algorithm, how many addition are there? 1, 2, 3. So 3 into TA. How many multiplication are there? 1 multiplication is there. So 1 into TM. How many division is there? 1 division is there. TD. And 1 subtraction is there. So 1 into TS. So total time required is this one. But the problem is, two problems are there. First of all, we have to identify the number of operation. Okay. And second problem is TA, TM, TD, TS, these are machine dependent. The values of TA, TM, TD, TS varies machine to machine. So we have to do something through which we have to represent time complexity by in any way so that it is machine independent. So the best technique is identify the number of lines. How many lines are there in this particular program, or how many lines it will execute. In this particular problem, it executes one line. So the time complexity is 1. Okay. So here how many lines are there? So to execute this line we need 1. Now 1 plus n. So for loop execute n times. So if it is n is equal to 4, then 1, 2, 3, 4. So 1 to n, it will execute n time. It satisfies n time, and there should be one dissatisfied when it will come from. It will return back from the loop. So it is n plus 1. So it is I is equal to 1 to n. So if n is equal to 4, it will execute 4 times. But there should be I is equal to 5 when this condition is not true. So that is the n plus 1 time it will execute. Okay. Next, it will enter into this loop n time. Okay, so it will enter, if n is equal to 4, it will enter into the loop 4 times, and here it is 1. This particular line is it is not outside of the for loop. So here we have used indentation. So please remember, use indentation to represent a program or to represent an algorithm. So it's the best practice to write a program, to represent a program with indentation. So if you use indentation, no need to give curly braces opening or closing braces. Okay, so it indicates that that means what? This particular line is inside the for loop. If here you have written the return is, that means the return is it's outside the for loop. Okay. Now, so total time required for that. So we have to add this one. So 2n plus 1, 2, 3. So time complexity is 2n plus 3. Okay. So here time complexity is 1. It is constant. And here it is 2n plus n. So time complexity depends on n. So the time complexity of this particular depends on n is large, it will take much more time. If n is small, it will take smaller time. Next, this particular algorithm, the time complexity, can you calculate time complexity for that? It's a very simple. We have to identify the number of lines. So it will execute one time, 1 plus n. So it will execute n plus 1 time. So if it n is equal to 4, so 1, 2, 3, 4 plus 1 time when it is false. Okay. And for j is equal to 1 to n, so it is once again n plus 1 for j, but this j is inside this I. So inside this particular loop, it is true for n time. It is true for n time. So how many times it will execute? So n time it will execute. So that's why it is n into this. So n into n plus 1. Now this one is inside this one also. So here it will execute n times. So total time required for that, for this particular line, n into this n. Are you getting this one? So it will execute one time. This for loop will execute n plus 1 time. N satisfied, 1 not satisfied. This inside the loop it is n time. This will execute n plus 1 time, but this loop is inside this particular loop. That's why n plus 1 into this n. Now this particular line is inside this loop also. Okay, so inside this loop it will execute n times. So total time is n into n. So that is n plus n, n into n. Now x equal to s, it is outside both the for loop. It is out the, so it will execute 1 times, and here it is 1 time. Are you getting? So total time complexity is n square here, n square plus this n square, okay, plus this n plus 1 plus this n plus this n, okay. Then how many remaining one are there? 1, 2, 3. So total 2n square plus 2n plus 4. That is the time complexity for this particular program. Clear? Now see this particular program. It will execute 1. Okay, now see here, you have to do something different thing. So if n by 2 is there, now suppose assume n is equal to say 8, or say n is equal to 2. So if you just divide few lines apart, now if n is equal to 2, so 1, okay, if n 2 is greater than 0, it is 1, s equal to, it will execute. Now 2 by 2 it is 1, it will execute. Once again, while come out from the loop, it will check. Now the present value of n is 1, 1 is greater than 0, it is yes, s is equal to yes, n is equal to n by 2. If n is equal to integer, then it will give result 0, it will execute. Once again, before come out the loop, it will check. So it is 1, but now the condition is false, come out from the loop and return s. Okay, now if n is equal to 4, it is 1 time, okay. So if it will execute 4 condition, next it will for 2, then 1, then 0, enter into this 3 times and 1. If n is equal to 8, so why we have chosen 2, 4, 8? Actually here it is divided by 2 is there, okay. So it is 1. So this particular condition, first time it is 1, 8, true. Then next due to this it will be 4. Next due to this it will be 2. Next will be this, it will be 1. Next the condition is false, 1. It will enter into this particular loop 4 times, 1, 2, 3, 5 times are there. So 1 less, 1, 2, 3, 4, and this one also 1, 2, 3, 4, and this is 1. Okay. Now we can see here always it is 1. Okay, but here it depends on n. So from time it is 3, then 4, then 5. Okay. Now if you assume log value, okay, suppose log 8. So log 8 is what? Log base 2, 8 is what? 3. So 3 plus 2, it is, how many lines are there? 5. So if you write log n plus 2, then we can represent this particular line. So base is 2. Now if log is 2, okay, so if n is equal to 2, then log 2 is 1. 1 plus 2, 3. See here 3. If n is equal to 4, then log 4 is 2. 2 plus 2, 4. 1, 2, 3, 4. Here it is 5. Log 8 is what? 3. 3 plus 2, 5. 1, 2, 3, 4, 5. Similarly, 2, 3, 4. Okay, so here we can write log n plus 1. Okay, so log 2 is 1. 1 plus 1, 2. Log 4 is what? Log 4 is 2, 1. So 2 plus 1, 3. Okay, so here also log n plus 1. Here it is simple 1 time. So total time complexity is 1, 2, 3. 3 log n plus 2, 3, 4, 5, 6. Okay, so the time complexity is 3 log n plus 4. Are you getting? So here the base is 2 because we have chosen n is equal to n by 2. If n is equal to n by 3, then base should be 3. If n is equal to n by 4, then base should be the 4. Are you getting this one? How to calculate this one? So why you have chosen log here? Because here the recursive type program is there. So how to execute this one? Now Tn we can explain like this way. Suppose Tn if equal to if n is less than equal to 0, so it will execute condition check and return. So it is 2. Condition check and return, it is 2. If n is greater than 0, then first condition check 1 plus return. Okay, so for return it will another it need another. Now remaining complexity recursive remaining t1 if tn if it is for tn, the remaining is what? T n minus 1. Are you getting this one? Now for example, suppose r sum a comma 4. Now here we need 1 for condition checking, 1 for return, addition and return 1, but it will call another once again. So r sum a minus 3 a comma 3, sorry. So if it is t4, it will be what? T3. So once again it will r sum a comma 2, then what? It is t2. That means to calculate this one we have to write if 1 else return 2, remaining is what? This t3. Here 2 remaining is what? T2. Here 2 remaining is what? T1. Are you getting this one? So that means Tn it is 2 if n is less than equal to 0, and if n greater than 0 it is 2 plus t the remaining n minus 1. So if it is t4, 2 plus t3. So if n is equal to 4, n minus 1 is 3. So 2 plus t n minus 1. Next we can write t n, just write one second. So Tn2 if n less than equal to 0. If n greater than 0, then 2 plus t n minus 1. Now here we can use recurrence relation. Okay, so 2 plus 2 for this plus t n minus 2. Okay, so for this one we can time this one 2 plus 2, this 2, this 2. Now from this 2 plus t n minus 3, 1 less. So the time complexity for t n minus 2 is what? 2 plus t n minus 3. Similarly we can do like this way, 2 plus 2 plus 2 dot 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 up to t n minus n. So 1 2 3 up to n. Okay. Now if it is minus 1, how many 2 are there? Single 2. If it is minus 2, how many 2 are there? 2. If it is minus 3, how many 3 are there? 3. If it is minus n, how many n should be there? 2n should be there. Okay, so if it is minus 1, one single 1 is there, single 2 is there. If it is minus 2, 2 2s are there. If it is minus 3, 3 2s are there. If it is minus n, n 2s are there, 2n plus t n minus 1 is what? N minus n 0. So if n is equal to 0, then it is 2. Okay, so for that we can write 2n plus 2. So t0 is 2. Why t0? N is equal to 0. If n is equal to 0, it is 2. So that's why here it is 2. So 2n is this one, t0 is 2. So total time complexity is 2n plus 2. Are you getting this one? So in this way we have to calculate time complexity for the recursive type program. Now see some more example. Now Fibonacci series is a very simple example. Okay, now if you can see here, if n is less than 1, so it will execute condition check plus return 1, so total time is 2. But if n greater than 1, if greater than 1, then condition check 1, the condition is false, execute else part. So in this, two lines are there, okay, semicolon, two lines are there, that's what is 2. For I is equal to 2 to n, so it will execute, so if n is equal to 4, so if n is equal to 4, the condition is true for 2, 3, 4, so 3 times. 3 times means what? n minus 1, so 4 minus 1 is 3, so n minus 1, but finally it will false one time, so it is n. Are you getting this one? So why it is n? So if it is 1 to n, the total for loop will be n plus 1, but if it is from 2 to n, it will execute for n time. Okay, condition will satisfy n minus 1 time, finally it will not satisfy the condition, so that's what is n. Now inside the loop it will execute n minus 1 time. Okay, so here total number of execution n minus 1, here two lines are there, so 2 into n minus 1, there is one single line. So if you add this one and if you add this one, okay, so the final answer time complexity is 4n plus 1. So addition of this, it is 4n plus 1. Next, can you execute time complexity for this? Can you calculate the time complexity for this particular program? Okay, now you can pause the video and okay, so it will execute one time. It is 0 to n. Suppose n is equal to 2, so the value of I will be 0, 1, 2, 3 times. So it is true for n times. Okay, and finally it will fall, so one time, that is it will execute n plus 1 time. Okay, so 0 to n, 0 to 2, it is n plus 1, that means 3 times, so 3 times is true, n plus 1 is true, plus 1 when it is false. Okay, now here it is 2 to m, so the value of m is say 2, or it is say 3, so 2 and 3, so one less, so it is n minus 1, and last time it is true, so n, so it will execute n time. Now inside this loop it will execute n plus 1 time, and it will execute m time, sorry, it is m time, so total of time m into n plus 1, it will enter into this m minus 1 time, and it will execute n plus 1, so it is n plus 1, and it is 1. Okay, so total time complexity is, actual time complexity is, okay, so the time complexity, if you add this one, you will get 2mn plus 2m plus 2n plus 5, that is the time complexity for this particular program. Next, very important, time complexity of insertion sort. Now you just take two instances. Suppose instance number 1, if the values are like this way, 2, 4, 5, so insertion sort, it's a sorting algorithm. So if it is 2, already sorting is there, 2, 4, 5 is there, and it's starting from 1. Okay, and second instance, if the values are like this way, 5, 4, 2, so 2, 4, 5 already sorting is there, but in ascending order. 5, 4, 2 already sorting is there, but in descending order. Now this particular insertion sort to sort a program, to sort a data in ascending order. Now if the data is already in ascending order, now we can say the number of times we can execute. So it is 2 to length A. Length means what? How many? Total size is 3. 1, 2, 3. Assume length is n. Total size is n. Okay. So j is equal to 2 to length n. Now if the value of n is equal to 3. So it will true for j is equal to 2, j is equal to 2 and 1 when it is false. J is equal to 4. Okay. Now if j is equal to 2, it will execute 1. It will execute 1. Now I is less than greater than 0 and ai is greater than key. What is j? First time j is equal to 2. So when j is equal to 2, then a2 is what? A2 is 4. The value of key is 4. And what is ai? I is j minus 1. J is equal to 2 minus 1. It is 1. So the value of I is 1. What is a1? What is a1? A1 is 2. Question is a1 is greater than a2. The condition is false. So it will execute, but it will not enter into this loop because this condition is false. Okay. So here it is 0. Here it is 0. And finally there is 1. Okay. Now when j is equal to 3, so it will, this loop, it will okay, this one it will execute 1, it will 1, this one, okay, it will execute. Now here also the condition is false. This particular condition is false, don't enter into this, and it is 1. Now if j is equal to 4, the condition is false. Now we can see here it is 1. So this particular line, it will execute how many times? 3 times. The value of n is 3. So line, we can give the line number here, say 2, 3, 4, 5, 6, 7, 8. So line number 2, it will execute n time. Okay, so 3, if n is equal to 3, it will n time. Line number 3, it will execute 2 times. The size of n is 3, so 2 times means 1 less, so n minus 1. Line number 4, it will also execute 2 times, it is 4 times. Now line number 5, it will execute n minus 1 time. 6 and 7 it will not execute. These two are the lines never executed. So it is 0. And 8 it will execute 2 times, so 8, line number 8, it is n minus 1. So total addition is 1, 2, 3, 4, 5. So 5n, 1, 2, 3, 4, 5n minus 4. So if the data value is, if the data is 2, 4, 5, then the time complexity for the insertion sort is 5n minus 4. Now we will see if the data is 5, 4, 2. Okay. So if the data is 542, so then what will happen? It is 542. Then if j is equal to 2, j is equal to 3 and j is equal to 4. So it will execute 1 time. Okay, it will execute 1 time, it will execute 1 time. The condition is true, enter into this, it will execute 1 time, it will execute 1 time, it will execute 1 time. Now we can see here what is j. J is equal to 2, a2 is 4. Okay, a2 is 4, that will transfer to the key, so key, the value of key is 4. I is equal to j minus 1, 2 minus 1 is 1. So a1 is what? A1 is 5. 5 is greater than 4, the condition is true. AI will transfer to AI plus 1. So what is in AI? AI in 5. That will transfer to I plus 1. The value of I is what? Now it is 1. So 1 plus and 2, the 5 will transfer to the I plus 1. So here should be the value is 5. Okay, I minus 1. So the value of I is, it is 1. Okay, so 1 minus 1, it is 0. Now I is greater than 0. No, condition is false. Come out from the loop. Now the present value of I is 0. 0 plus 1, 1. The key value will transfer to the A1 value. What is key value? Key value is 4. 4 will transfer to this. Now the value, the present situation is 4. So initially it was 542. Now it was 452. Now if j is equal to 3, it will execute 1. It will execute 1. It will execute 1. Now it will execute 2 times. Okay, sorry, it will execute. It will execute 2 times when it will check I is greater than 2. Okay. Now it will execute 3 times, it will execute 2 times, it will execute 2 times, and it will execute 1 time. You can easily check if you dry run this particular algorithm. If you dry run this particular algorithm, you can see here that how it is working. Now in this case it is false. Okay. Now line number 2, it will execute 3 times. The value of the size is, say, size in, it is 3 times, so we can say line number 2, it will execute n times. Line number 3, it is 2 times, one is one less, so n minus 1. Line number 4, another 2 times, line number 4, n minus 1. Now line number 5, we can say something interesting part. First time it is 2, then 3, then it will be 4, then 5. So a one series is there. Line number 6, another series is there, 1, 2, 3, 4. Line number 7, another series is there, 1, 2, 7. And line number 8, it is 2. 2 means what? It is n minus 1. Okay. Now we have to solve this particular series. So how to do this one? Okay. So line number 2, it will take n time. Line number 3, n minus 1. Line number 4, n minus 1. Line number 5, it is series. It is a series 2, 3, 4, 5, 6. It is up to, so it will up to, it finished up to 2 and 3, means up to n times. Okay, n is equal to 3. Here it finishes up to n minus 1. Here it is n minus 1 up to n minus 1, but starting from 1 up to n minus 1, starting from 1 up to n minus 1, starting from 2 up to n, because the value of n is 3. So 2 and 3. Okay, it will execute up to 2 times. So 1 to n minus 1, 1 to n minus 1. Okay, so 2 to n. So we know the series 1 plus 2 plus up to n. So n into n plus 1 by 2. So if it is from 2 to n, then n into n plus 1 by 2 minus 1. Okay, and if it is 1 plus 2 to up to n minus 1, so n minus 1 into n minus 1. So if you substitute n with n minus 1 by n minus 1, so n minus 1 plus 1, so final answer will n into n minus 1 by 2. Okay, so line number 2, it will take n time. Line number 3, n minus 1. Line number 4, n minus 1. Line number 5, it is n square by 2 plus n by 2 minus 1. Line number 6 and 7, both are same. That means 2 into n square by 2 minus n by 2, 2 because 2 lines are there. And finally line number 8, that is n minus 1. Okay, so n square, so if you solve it, we can get like this way. Okay, now if you solve it, we can get 3 by 2 n square plus 7 by 2 n minus 4. Okay, so if the instance is first instance, we can know the 2 instances are there. If the value is 2, 4, 5, the complexity is 5n minus 4. So type instance number 1, the complexity is 5n minus 4. 5n minus 4. If the instance is second, the complexity 3 by 2 n square plus 7 by 2n minus 4. Okay, now 3 terms are there: best case complexity, best case, worst case, and average case. Now best case means minimum time required to execute. So this is the best case condition. This is the best case condition, minimum time required to execute. Worst case means maximum time it requires to execute. This is nothing but a worst case condition. Okay, now sometimes it is very difficult to identify best case and worst case, so for every instance we take the average. Okay, for every instance we calculate the time complexity and then average it. That is called average case time complexity. Okay, and that is the end of this particular video.